Hello everyone, welcome to the first proper topic in this geography playlist, or geography channel rather, and it's going to be focused mainly on this thing known as plate tectonics. So what we're going to be doing in this section, most of the following: the structure of the Earth, then we're going to do the theory of plate tectonics, continental drift and seafloor spreading, and how they sort of are merged into one when we talk about the modern plate tectonics theory. We're going to be talking about Pangea in relation to these. Then we're going to be talking about plate boundaries and volcanic hotspots, which kind of link into each other. So we're going to be talking about the Earth's structure first of all, because that's going to be important for the next couple of chapters. The Earth consists of several layers. The uppermost is known as the crust. It consists mostly of tough minerals such as pure elemental silicon and aluminium. Now below that is a layer called the mantle. However, there's a tiny boundary that marks where the crust ends and the mantle begins. It is simply called the Mohorovic line, but the actual name for it is the Mohorovic discontinuity, which is a name I definitely mispronounced. Now the layer below the crust, as I said, is called the mantle, and it's split between solid mantle and liquid mantle, so it's also known as the upper and lower mantles, respectively. It consists mostly of iron and magnesium, so if you can think, those metals have melting points well over, in and around 2000 Celsius. So imagine those being liquefied underneath the Earth. The layer containing the solid parts of the Earth structure are known as the lithosphere, and the slightly liquid portion underneath of it is known as the asthenosphere. Okay, so a couple of keywords to note there, especially for essays, which we will discuss. So don't worry about that. Now, as we go deeper into the liquefied part of the Earth, we encounter what's known as red hot temperatures, so in and around 4000 Celsius ish, as far as I can remember. The lower mantle contains iron and magnesium, as well as rich silicates. So silicate comes from silicon, and it's just compounds which contain silicon. So borosilicates, I believe, is boron and silicon, and some other sort of silicate related things. Now below the mantle is a thing called the core, which is the very center of the Earth. It contains iron and a new element, nickel. It's several kilometers thick, so it's actually the thickest of the layers, and is about 6,000 kilometers down from the surface, which means the Earth's radius is about 6,000 kilometers. Just a fact. Now here is an artist's rendition of what the layers look like. If you want, you can pause and try name each of those layers. So I'm going to do them now. Obviously, this grey area is the crust. Then we have the upper mantle and lower mantle, and then of course the outer core and inner core, respectively. Now, before we go on to the next section, I am just going to briefly mention the crust, because the crust is where we get plates from. So the crust can be split into continental oceanic crust, on which we have continental oceanic plates, where a plate is just a large chunk of the crust, which can be land or ocean. Continental is mostly land, and oceanic is mostly ocean. Now, oceanic plates are denser than continental plates because of the way that they're composed. It's made up of pure silica and pure magnesium, which is often abbreviated to SiMa, whereas continental plates are less dense and are made up of silica and aluminium, which is abbreviated to SiAl. So both have silicas, but magnesium and aluminium is how they're different. Now, despite their name, there can actually exist continental and or oceanic plates which contain both ocean and land. We will get onto what's known as the tectonic map, but the North American plate, for example, is in and around parts of northern Mexico, Canada, and the contiguous US, but also has bits in the Caribbean Sea, or just north of the Caribbean Sea, as well as the Atlantic Ocean. This can also be the opposite, so the oceanic Pacific plate also has places like Hawaii and all the tiny islands are in there. Now, how the plates move is due to rotational energy within the liquefied part of the Earth's mantle, so forming these things known as convection currents. So there's sort of little spirals of energy within the mantle that cause them to move. However, they are extremely slow, growing at a rate similar to that of your fingernails. So the more your fingernails grow, the more the crust either converges or diverges to a certain point.